All right, by now you know the drill. We're going to have to figure out how you can divide functions. In our last video, we looked at how to multiply two functions together and find the derivative of that product of functions. And we noticed that it wasn't simply the derivative of each of the pieces multiplied together. There was something a little bit more complicated going on. Here, we're going to do the same kind of thing, but now we're going to be talking about division. So our goal for right now is that we want to be able to find a derivative of a quotient of two functions that we know. So in all four of these examples, we've got this division. Now notice that we don't always have to use a special rule. For example, if we had something that was like f of x equals x plus 4 over x, then we can use that upside down triangle to write this as 1 plus 4 over x, or 1 plus 4x to the negative 1. And now we can find the derivative. The derivative of 1 is 0, and we've got negative 4x to the negative 2. So we don't always have to use some sort of a rule here to find the derivative of something that's written as a fraction. But if we can't simplify it using some algebra, then we will have to. So notice that all four of our examples that we've got here are something that we can't simplify. Here we've got a triangle, but it's the wrong way around, so we're not able to like split this up into multiple terms or anything like that. This one we kind of, I guess, could, but it's not very nice. It doesn't do much for us. We're still going to have these ugly quotients, these ugly fractions that we won't be able to just write with negative exponents. So what we can do now is try and figure out what the quotient rule is. In the last video, what we did was we took an example and we said, hey, I know how to multiply these two functions together. I know what my answer should be. Let's come up with a way of getting that. What I'm going to do now is say, let's take this quotient, u over v, and we're going to rewrite it by multiplying v on both sides. So I'm just multiplying that to bring it up over here. And I want to find f prime of x. Now, this is kind of difficult to do, but what I'm going to do is really say find u prime of x. And you should notice that here we have a little product. So what we can say is that u prime, and maybe I'll just write it this way, is equal to our product rule. Now, I'm not going to call these u's and v's anymore because I already have them written as u's and v's. But I've got v and f. And so I'm going to say one function multiplied by the other derivative added with the opposite thing. So I'll say f v prime. Is that right? Yeah, v and v prime, f prime, and f. Cool. Now, if I'm trying to find f prime, I've got one in here. So let's go ahead and solve for f prime. So I'm going to subtract this stuff. So I've got u prime minus f v prime equals v f prime. And then if I want to solve for f prime, I'm going to put it on this side. All I have to do is divide by v. So I've got u prime minus f v prime over v. That's supposed to be a prime. There we go. Cool. Now, notice I have this written with an f in here. I want to write it only in terms of u and v. I know what f is, though. F is u over v. Oh, that's a brutal circle. Let me fix that. There we go. That's better. So I'm going to take that and I'm going to plug that in for f. So really what I have is that f prime equals u prime minus u over v, v prime over v. This is really ugly looking though. I've got this complex fraction, sometimes people will call it, where you have like a fraction inside of a fraction. The way that I'm going to get rid of it is by multiplying every term in this thing by this denominator v. Basically, I'm going to multiply v on the top and v on the bottom. I'm going to have to use the distributive property. Maybe I'll write it out like this. So really I'm multiplying by 1, right? V over v. But I'm going to have to use the distributive property here. And so I've got v u prime minus, which one is this? Oh, sorry. So I'm going to multiply the v on this fraction. It's going to cancel things out, and I've got a u v prime. I went brain dead for a second. And then on the bottom, I've got v squared. I thought I made a mistake on something, and then I got really confused. Anyways, here we go. This seems really strange, but this is our product rule, or our quotient rule. Notice that we got it by using the product rule and just rewriting our functions. And we're basically saying any sort of division we can rewrite as another equation with multiplication in here. And then we can find derivatives using the product rule and solve for f prime, and we get back to this nice little quotient. So if we've got a quotient u over v, this is our rule for how to find the derivative. It's a little bit more complicated than what we're used to with the product rule. But notice that it's still written in terms of u's, v's, u primes, and v primes. So here's the cleaned up way of writing this. Here's a really bulky version with all the x's in here, and then I've got it written without. So v u prime minus u v prime over v squared. I know of a couple of little memory techniques for this that people will use. The first is the classic low d high minus high d low. What the heck does this mean? Low d high minus high d low is a memory tactic to remember the ordering of this vu prime minus uv prime over v squared. Because u is always the numerator and v is always the denominator of our fraction, we can say v is going to be the low part and u is going to be the high part. D is going to stand for derivative. So this part here is low d high minus high d low, or v low times the derivative of u d high minus high u d low, the derivative of v. Sometimes people will say things like over low to talk about this division by v squared, which I think sounds ridiculous, but whatever. Now, this little mnemonic device did not work for me when I was an undergrad. For me, I could remember the rhyme, but I could never remember the order of the rhyme. I couldn't ever remember if it was low d high minus high d low or if it was high d low minus low d high. And that's really important because if we switch the order of this, if we subtract these in the wrong order, we're going to get a wrong sign, right? 7 minus 2 is 5, but 2 minus 7 is negative 5. Same number, opposite sign. So it's really important to remember the order, and so this little mnemonic device for me wasn't helpful at all because whether it was low d high minus high d low or high d low minus low d high, I couldn't tell the difference. To me, it sounds like hi ho, it's off to differentiate we go. So that one was never terribly helpful for me, but for some people, it has been. Another thing that I've seen people do, and that I kind of like, is looking at these v's. There's a v prime, and there's a v squared. And if we just put those in, the rest of it is pretty easy to remember how it works. So let's just focus on this pattern of v's here. First off, notice that the v's make a big V. That's kind of cute. Also, this prime here, that little tick mark, we know it means that we're talking about the derivative of v. But if we pretend that we don't know much about calculus, this looks a lot like v, v1, v2. So if we just kind of go around here, we can kind of figure out how this works. And the rest of it's easy to fill in. There's a fraction bar. There's a minus sign. Sometimes it's hard to remember that, but I always remember that minus goes with division because plus goes with multiplication in the product rule. We add those things together. And then filling in the u's I think is easy because if this is v, then this one's u prime. And if that's v prime, then this one's just u. We always remember that one function goes with the other derivative. So we could do something like that. The other way that I know, and this is really the way that I did as an undergraduate, the one that kind of kicked in for me, is I would just organize it the same way every time. I would write out u and v this way, and I'd write out u prime and v prime this way, and then my muscle memory just said always multiply this pair first. That's not a very exciting way of remembering it, but I think there is something to say for just forming a good habit. Try and look up and see if there's some other memory techniques for this, because these can be a little bit tricky to fill in. I'll write out the actual quotient rule for the first couple of examples while we get used to it, but let's see what we've got going on here. So maybe I'll just write out my u's and v's. I'm going to write them way over here off to the side so I get a lot of room. So I'm going to write u, it's going to be always my numerator, x plus 1. And v is always my denominator, x minus 2. U prime is 1, and v prime is 1. And so the derivative that we're going to be looking at is v u prime minus u v prime over v squared. So here we go. Let's see, these two first. I'm going to not write the 1 on there because it's kind of boring. X minus 2 minus uv prime, these two things being multiplied together. So now I've got x plus 1 all over v squared, x minus 2 squared. Cool. Couple of things. First, a lot of people will do this. Don't do that. That's not right. That's not how we cancel things out. That's not how we factor things. Notice that for things to cancel, they have to be pulled out as a factor because we really are noticing that we're multiplying by something over itself. That's not what's going on here. The other thing that people will do is they'll forget about this minus and they'll say, okay, x minus x, so that's going to be like 0, and then they'll say negative 2 plus 1. Basically what they'll do is they'll forget about these parentheses here. And then they'll end up with something like negative 1, which isn't actually the case. If we put these parentheses on here, we notice that the negative sign impacts this whole x plus 1. So we really have negative 2 minus 1, which is negative 3 over x minus 2 squared. So that's our derivative. We got to be careful here for a couple of different reasons. First, the form of this quotient rule is hard to remember, I think. It takes a little while for us to get used to it. Second, it's very easy to mess up that algebra rule where we cancel things. And third, don't forget that you're actually subtracting everything in that second piece. We'll see more of that in a second. This one wasn't too bad because there's not a lot of hard multiplication to do, but that's what we've got. Go ahead and try this second one. I'll write up the u's and v's again. But if you want to pause it right now and get going on it, that'll work out pretty well. All right, if you're back, we can kind of check this stuff. Or if you're just trying to get a hint on how this gets set up, here you go. These are our pieces. We're going to multiply these two things first and these two second. We're going to fill it into this form. And this is what it looks like. F prime of x is equal to vu prime. I'm going to write it u prime v, I guess. I'm going to write the 2x out front. I like putting the smaller thing first because I like to distribute from the left. It's no different. Multiplication is commutative. Doesn't matter what order you do it in. Who cares? And then we'll do these two things. I think we can just multiply that in our head. That's just 3x squared. Over 3x plus 4 squared. So now I've got some distributive property to do. So I've got 6x squared minus 8x minus 3x squared over 3x plus 4 squared. 6x squared minus 3x squared is 3x squared minus 8x over 3x plus 4 squared. And now a couple of people might want to multiply out this x minus 2 squared and in the bottom one the 3x plus 4 squared. You can do that, but what I would do is leave it first because I'd notice right off the bat that I've got a factor or a common factor that I can pull out here. I can pull out x, and now I've got 3x minus 8 over 3x plus 4 squared. Why is that helpful at all? Well, it's possible, not very likely, but it's possible that if we factor out this numerator, we get a 3x plus 4 factor, in which case we could cancel them out. So I like leaving everything in the denominator as this 3x plus 4 squared, so I can see what the factors actually are, and then I'll try and factor the numerator. I'll take whatever version of these you want to give me. That's fine, but we'll find that later on this semester it's going to be helpful to have it factored, so I'm going to try and factor it as much as I can whenever I see it. All right, here's two more. Go ahead and give these a shot. and we'll see what happens. I'll see you on the other side if you want to pause this and come back. All right, if you're back, I'm going to fill out the u and v primes and all that stuff for both of these examples. And then, again, if you want kind of a hint, that might be a good way of starting. All right, e to the x over x. The derivative of e to the x is e to the x. The derivative of x is 1. And here we've got x cubed plus 1 over ln x. The derivative of x cubed plus 1 is 3x squared. And the derivative of ln x is 1 over x. Now remember that we're looking at vu prime minus uv prime over v squared. So again, if you want to take a second and finish this up, go for it. I'll see you on the other side. Okay, here we are. F prime of x is vu prime, these two. So that's going to be x e to the x minus uv prime, these two, e to the x, over v squared, that's x squared. So now, again, I might notice I can factor some stuff. You could notice there's an upside down triangle, so there's a couple of different things you could do. You could say this is like e to the x over x minus e to the x over x squared. Or you could say this is e to the x times x minus 1 over x squared. Those will work. Any of those three are fine. There's really not a lot that we can do here. Again, personally, I'll probably use this third one because I like to see that it's factored. What we could maybe notice is that if I put 1 into this derivative, that whole numerator is going to turn out to be 0, meaning the whole derivative is going to turn out to be 0. Meaning when x is 1, the slope of the tangent line is 0, meaning there's a horizontal tangent line there. That's going to be important later on. So again, I'm going to factor as much as I can out of this stuff. All right, second one. F prime of x is vu prime. I'll write that as 3x squared ln x minus uv prime x cubed plus 1 over x over natural log of x squared. I'm going to multiply everything by x over x to get rid of this x. So now I've got 3x cubed ln x minus x cubed, and notice that's in parentheses, so I'm going to distribute that negative, so it's really minus 1 over x natural log of x squared. This is super ugly. There's not a lot that you can do here. We can't combine these things together because they're not like terms, because this middle one doesn't have a natural log. We can't pull out a common factor because we've got this third term here. I mean, if you wanted, we could try and split up this fraction into 3 different things put together. You could do that if you want, but it's kind of ugly. You'll notice that whenever there's logarithms inside of quotients and stuff like that, the derivative turns out to be pretty hideous, but oh well. We can still do it. This is still what this will look like. All right, there's 4 examples. I think that'll give you a pretty good head start on how to deal with this. Again, don't fall into the trap of looking at just the derivative of the top and just the derivative of the bottom. That's not how things are going to work here. That won't be a helpful way of dealing with anything. So don't look at this and say, oh, the derivative of e to the x is e to the x, and the derivative of x is 1. Don't say that this is 3x squared over 1 over x. That's not how these work. All right, go ahead and give a shot to some other problems and let me know in the discussion boards if you have any questions on any of this stuff.